Okay, so this is going to be my first video for chapter 5. I guess I'll write that there too. I'm hoping that these videos, I'm planning on, this is the first of 4 of them, but I'm hoping that these videos will help those that have been absent maybe when we started chapter 5, that this will help you to get up to speed. Maybe those that are just still maybe a little bit confused, you can watch the portion of the video or watch the video that you think might help you best. So these are the topics that we're going to cover in this first video. We're going to talk about the number of valence electrons that are in each group. Groups, don't forget, are our vertical columns on the periodic table. We're going to learn how to identify the blocks on the periodic table, and we're going to identify charges when an atom becomes an ion. Don't forget, an atom, in order for an atom to become an ion, it has to gain or lose electrons, okay? Atoms don't gain or lose protons. If they gain or lose protons, then they turn into something different. Okay, they turn into a different element because a proton identifies what element it is, and electrons determine reactivity, okay, and behavior, how that atom is going to behave, how it's going to interact or react rather with other atoms, okay? And lastly, we're going to look at Lewis dot diagrams, also known as electron dot diagrams, okay? All right, first, let's look at the number of valence electrons that are in each group, okay? And I have made several periodic tables that we're going to be looking at. Here's the first one. This is similar to the periodic table that I posted last week. It is shaded, showing you the different blocks that are on the periodic table, which we'll get to in just a moment. Okay, first of all, groups. We call them groups. Well, we don't, but they are called groups. Groups are the vertical columns on the periodic table. So this here is group 1. This one here is group 2. We're going to skip the middle here. These are our transition metals, and we're going to skip these because, as I always say, these are kind of the rebels of the periodic table. They don't always follow by the rules. So we're going to skip those for right now, and we're going to come back and talk about those more in detail when we talk about bonding, okay? So, excuse me. So this is group 3A, okay, because you see here it's really group 13, but we call it group 3A because if we call it group 3A, then that tells us how many valence electrons it has, okay? So I'll get to that in a moment. This is group 4A. 5A, 6A, 7A, 8A. Okay, so our noble gases, those are called group 8A. Okay? So, group 1 has 1 valence electron. And you see I have written up here 1 V period E period. And that V period E period stands for valence electron. Okay? So that has 1 valence electron. So all of these elements in group 1, they have 1 valence electron. Group 2, they have 2 valence electrons. Okay, so all these in this group, they have 2 valence electrons. Okay, now you see that this yellow is highlighted, and we'll get to what those different colors of the highlightings mean. But you see that helium is also yellow. And helium, even though it's over here, we'll get to why it's over here in a moment, but helium only has 2 electrons, okay? It only has 1 energy level, and it only has 2 electrons. So that outer energy level is full, which is why it's in the noble gases, but it only has 2 electrons, So it kind of goes over here for that purpose as well. But since it is, it does have a full outer shell, we leave it over here with the noble gases because it is what is called inert. And under normal circumstances, helium does not interact with other atoms, okay? All right, so now we skip on to group 3A. Group 3A has 3 valence electrons. Group 4A has 4 valence electrons. You got it. Group 5A has 5 valence electrons. 6 has 6 valence electrons. 7 and 8, okay? And again, that helium does not have 8 valence electrons. It only has 2 electrons total. So, of course, it's valence electrons, which, let me sort of backtrack for just a moment. Valence electrons, the word valence refers to outermost. So, valence electrons refers to the outermost electrons, okay? All right. Now, so that's the number of valence electrons that are in each of these, okay? Each of these different groups. And again, we skip the middle and we skip these down here. These down here are called our inner transition metals, and we'll get to just a moment why these are highlighted, okay? All right, so actually let's talk about why those are highlighted, those different colors now. Okay, so this is considered the S block, and this S, P, D, and F, we have to understand these when we get to electron configuration, okay? And we're going to talk about that in video number, let me see, video number 3, we get to electron configuration. But I do want you to know what these different blocks are. So we have the S as in Sam block. You see that right up there, S block. Then we have the P block, and you see that up there, P block, P as in Paul. Then we have the D block, D as in dog, and then we have the F block down here, F as in Frank. Okay, so S, P, D, and F. All right. Now, I'd like to talk about those blocks for just a moment. And we have, as I said, we have the S block. And first of all, an orbital, before I talk about the different blocks, an orbital can hold a maximum of 2 electrons. Okay, of 2 electrons. That looks like a C more than an E. There we go. It looks can hold a maximum of 2 electrons. Okay, so the S block only has 1 orbital. Okay, so of course, since each orbital can only hold a max of 2 electrons, that S block can only hold a max of 2 electrons, right? Which makes sense. If the S block only has 1 orbital and each orbital can hold 2 electrons, that makes sense that the S block can only hold a maximum of 2 electrons, right? So then we have the P block. Well, the P block has 3 orbitals. And the P block, or the P sublevel rather, the P sublevel, I keep writing block here. I'm going to change this to sublevel because really I have that mislabeled. When we refer to these locations on the periodic table, these are called our blocks, okay? But I'm talking about these sublevels, okay? So we have an S sublevel. It has 1 orbital. It can hold a maximum of 2 electrons. We have a P sublevel, and it has 3 orbitals, and it can hold a max of 6 electrons. Okay, then we have a D sublevel. Whoopsie. Sorry about that. Actually, that's not bothering you, but I can't see what I'm recording here. Okay. All right, then we have a D sublevel. And this has 5 orbitals. And the D sublevel can hold a maximum of 10 electrons. Makes sense, right? If there's 5 orbitals, each orbital can hold a max of 2 electrons. 5 times 2 is 10 electrons. And in the F, as in Frank, sublevel, there are 7 orbitals. And of course, the F sublevel can hold a maximum of 14 electrons. Okay, now I've told you several times that I am not into making you memorize unnecessary information, right? Well, I just gave you a lot of numbers and a lot of information that you're probably like, oh my gosh, how am I supposed to remember this, right? Well, let me show you. So as I said, the S sublevel, okay, we're talking about energy levels. Okay, this is the Bohr model, okay, and in this first energy level, there's an S sublevel. That's all that's in that first energy level, okay? In that first energy level, there's only an S sublevel. It has 1 orbital, and it can hold a max of 2 electrons. So this first energy level, this right here, if this in here is our nucleus, okay, so if this is our nucleus, so that's where our protons and our neutrons are. Our electrons are out here in these orbitals, in these different energy levels, okay? So in this first energy level, there's only an S sublevel, okay? And in that first sublevel, there can be 2 electrons, a max of 2 electrons. Okay, well, remember, I just said I don't like to have you memorize things. So in this first energy level, I'm going to take my piece of paper and I'm going to kind of cover up everything else because they only want to look at the first row. And remember the other day we were talking about, we read a book from left to right and top to bottom, right? And we read the periodic table just the exact same way, okay? So the first energy level is represented by that first row. And that first energy level only has 1 S sublevel. Okay, the first energy level has 1 S sublevel. And that can hold 2 valence electrons, right? Or 2 electrons total. Okay, well there's 1, and then remember helium is kind of over here. Okay, so there's 2 electrons. So those 2 blocks kind of indicate to us, or our cue, or our memory trick, or whatever, that S sublevel can, that 1S sublevel can only hold 2 electrons. Okay. Now we go down to the second row. These are called periods. Okay, and this represents the second energy level. Okay, and actually I'm going to switch periodic tables on you just for 1 second, or for a few minutes actually, because I have these labeled. Okay, so in this second energy level, I have a 2s and I have a 2p. Okay, I have a 2s and a 2p in the second energy level. Okay, so this 2s can hold 2 electrons because remember, I just said s's can hold 2, and this 2p can hold a max of 6, right? So in that second energy level, I can hold a maximum of 8 because there's 2 here and there's 6 here, there are 8 electrons that can be held in that second energy level. Okay? Now, do we have to memorize that? No, because we have 2 blocks here that represent, they serve as a memory trick for that 2s, and then we have 6 blocks here that that serve as a memory trick for that 2p sublevel. Okay, so there's 6 electrons there. So 2 and 6, that's 8. All right, now we move on to the third energy level. Well, the third energy level, we have 3s, and there's 2 blocks here, so that can hold 2 electrons. We have 3p, and we have 1, 2, 3, 4, 5, 6, so that can hold a max of 6 electrons, right? Yes. Okay. Then, and this is telling us the order in which they fill, okay? In the order in which the electrons fill the orbitals, okay? Listen again. I'm going to say it again. The order in which the electrons fill the orbitals, okay? So after we fill the 3p, then we come down here and we go 4s, 1, 2. So 2 electrons go in that orbital in the 4th energy level in the s sublevel. And then we go back to that 3rd energy level, okay? The 3d sublevel is slightly higher in energy than the 4s. And the electrons always fill the lower energy levels first. So it's kind of unique in the sense that it starts filling the 4th, and once it fills that 4s sublevel, it drops back down and fills some more in on the 3rd energy level. Okay? And then we go back, and then you see over here I have 4p. So then after it fills 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you remember, D has 5 orbitals, holds a max of 10 electrons. Whoa, this is making sense, right? Okay, so then I have 10 there. And then 4p, I have 1, 2, 3, 4, 5, 6. I have 6 electrons there. All right. Now we go down, and I have 5s, 2, 1, 2, right? Then remember we have the 4d orbital has slightly higher energy than the 5s. So then after it fills that 5s, those 2 electrons fill that 5s, then we start filling the 4d. And I fill 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in the 4d. And then we go back and we finish filling some more in that 5th energy level in the 5p sublevel. And we fill 1, 2, 3, 4, 5, 6 in that. So on and so forth. We keep going like that. Now, there's a little trick I'm going to show you, because I keep telling you, I am all about trying to give you different ways to help you remember things, because I'm hoping that one of these is going to be easy for you, and then you're going to go, oh, I like that one best, and then it's going to be easy. If you write all of your ones here, and all of your s's here. So you write 1s, 2s, 3s, 4s, 5s, 6s, 7s, okay? 2 starts with P, or P starts with 2, okay? Because remember, there's not a 1P, right? So we go 1S and we come over here and there's not a 1P, right? So then we have to go down a row. We go back over here to the left and we have 2S and then we have a 2P. So then we write all of our P's. So we have 2P, 3P, 4P, 5P, 6P, 7P. Okay, so we have 2P, 3P, 4P, 5P, 6P, 7P. Okay, makes sense. Then we write our D's. D starts with 3. Okay, D starts with 3. So we write 3D, 4D, 5D, 6D. There's not a 7D. Okay, so don't get, over anxious or whatever, overzealous, and because we only have 3D, 4D, 5D, 6D. Okay, so our D stops with 6, and then F starts with 4. Okay, so we have 4F and 5F, and our F block is down here. So we have, there we go. So we have 4F and 5F down here. All right, so then we take our straight edge and we just draw arrows. Okay, so this 1S fills first, then we go to our 2S, then we go to our 2P, 3S, 3P, 4S, 3D, 4P, 5S, 4D, 5P, 6S, 4F, 5D, 6P, 7S, 5F, 6D, 7P. Okay, so that's the order in which the electrons fill the atomic orbitals. All right, so I think I've got that. Now we're going to move on to the charges that an atom has when it becomes an ion. Okay, so remember I said that this first group has one valence electron, right? Well, let me tell you a story. Atoms want 8 valence electrons. They want 8 electrons in their outermost shell. Okay, always. Okay, they want 8 valence electrons, except for helium. And it's perfectly happy with just 2 because it only has an S, and hydrogen doesn't want 8 either. Hydrogen is actually happiest when it has no electrons, but we'll get to that in just a moment. Okay, so group 1, when group 1, which is this group right here, when group 1 becomes an ion, it is going to lose an electron, so it's going to have a 1+ charge. And we'll look at that a little bit more in depth when we look at our Bohr models of the atom, which we do in video 2. Okay, so when group 1 becomes an ion, when these atoms become an ion, they turn into a 1+ ion. When group 2 becomes an ion, they lose 2 electrons, so they turn into a 2+ ion. We skip the middle, right? Because those are our rebels of the periodic table. They don't always follow the rules, so we're going to skip those for right now. We're going to go on over here to group 3. Group 3 loses 3 electrons, so it becomes 3+. We're going to skip group 4 for now because group 4 does not routinely form ionic bonds. Okay, there are a couple of atoms that do. Okay, tin and lead. Okay, these two do routinely form ions. Okay, but they have multiple oxidation numbers, and so we're going to skip this one right now. These numbers, by the way, I just said a buzzword that I want to make sure that you understand. These these numbers that I have up here are called oxidation numbers. Okay, so this 1+, 2+, 3+, and then I'll get to my minuses right now. Okay, so we're going to skip this group 4A for right now. Group 5, okay, group 5A, they have 5 valence electrons. They are almost to that 8, right? They're not going to give up, okay? So they're going to, what I call, beg, borrow, or steal to get those final electrons that they need. So they routinely gain 3 electrons, and when they do, then they have a resulting 3- charge. Group 6A, they have 6 valence electrons, so they're almost to that full octet, meaning that full outer shell set of 8 valence electrons. So they're going to gain 2. resulting in a 2- charge. And group 7A has 7 valence electrons, and it's like, oh my goodness, I'm almost there. So it's going to gain that last electron so that it ends up with a 1- charge. And group 8A, which are our noble gases, they do not routinely react. And so we just say that they have no charge. Okay, they don't routinely have an oxidation number. Okay, so those are our charges when those atoms become ions. All right, now I want to have the periodic table that shows the number of valence electrons that each of these has, because now the last thing we're going to talk about today is drawing our Lewis dot diagrams. Okay, so I guarantee you guys have done these. This is review. I'm only going to do about 2 or 3 of these because, as I said, I guarantee you guys have done these before. This is review from probably 8th grade, and most of the time you touch on this again in biology as well. Okay, so let's look at nitrogen, because that's what I did in my classes earlier today. So nitrogen we're going to look at is right here. It is in group 5A. Okay, so it has 5 valence electrons. Okay, just to refresh, 1 valence electron, 2, we skip these, 3 valence electrons, 4, 5, 6, 7, 8, right? So nitrogen's group has 5 valence electrons. Well, with Lewis dot diagrams, we write the chemical symbol on the paper, and then we draw dots in either the top or the bottom or the left or the right of the chemical symbol. And these dots represent valence electrons. Okay, so nitrogen has 5 valence electrons. So we're going to put these top, bottom. I always do it top, bottom, left, and then right, but it does not matter. Okay, and I need 5 dots, right? So I'm going to draw one more up on one of the sides. So either the top or the bottom or the left or the right. Don't put them on the corners. Okay, make it very clear on the top or the bottom or the left or the right. Okay, we don't put them here or here or here or here. Okay, we put them literally in, top, bottom, left, or right. And that's the order that I do them in. You can do it like this. So if you want to do this one, and you want to put 2 on the bottom, that's perfectly fine. If you want to have 2 on one of the sides, perfectly fine. It doesn't matter. Okay, so that's nitrogen. Let's do magnesium. Magnesium's over here. It has 2 valence electrons, right? It's right there. 2 valence electrons. So we're going to write magnesium. So we write Mg. And we need 2 dots. And I always, as I said, I do top, bottom, left, and then right. But I only need 2 dots, so I'm just going to put one on the top and the bottom. Okay, if you want to put them like this, one on top, one on one of the sides, totally fine. If you want to put it one on the bottom and one on the side, totally fine. But I just want 2 dots though. Okay? All right. So that, I believe, is all I have for video 1. Again, thank you so much for tuning in. Our next video is going to talk about the Bohr model of the atom, and I'm going to talk about how this Bohr model relates to the number of valence electrons. Okay, so that's going to have some important stuff in it. All right, thank you so much. I will talk to you guys soon.